Okay, let's show you what you're going to do today. We are going to be working through a new section, the final section, and it's called trig substitution. I like to call it X sub for short. And normal substitution, I call them U sub. These guys we call X sub. And what you're going to be doing is a form of substitution, but it's similar, but not the same as U substitution, right? The ones you're used to. It's called trig substitution. It's a bit strange, that shouldn't be there. It's called trig substitution because the substitutions that we use are one of these three. It's going to be 3 sine theta or 4 secant theta or 5 tan theta. And we're going to use it in a very specialized way. You use it when you want to do integrals, and typically, but they don't need to, but typically they have square roots. But more importantly, they have an x squared in them. So it's going to be x squared minus a number minus x squared, or x squared plus a number, right? That's the three main situations. When there is a like 5 squared, take away x squared, you're going to use this substitution, x equals a sine theta. Here it's going to be a secant theta, and when the two things are added, you're going to use a tan theta. So for instance, in this one here, the x sub that we're going to use, because it's 16 take away x squared, it's this guy, is going to be 4 sine theta. Substitution we're going to get here is going to be 2 tan theta. And substitution we're going to get here is going to be x equals 3 secant theta. Are we comfortable with how to pick the right x substitution depending on what's happening with the x squareds? So you know how it's called a squared minus x squared? That's 4 squared. That's why that's 4 sine theta. See how this says 4 plus x squared? That's a 2 tan theta. See how this is an x squared minus 9? That's a 3 secant theta. So if somebody went and gave you an integral and it had, I don't know, the square of x squared minus 25 in it, wouldn't you use 5 secant theta? X squared minus 1, you use 1 secant theta. Even if it says something like x squared minus 82, wouldn't you do the square root of 82 secant theta, right? So let's take you through. My goal is to get these 3 questions done. That's quite a big goal, actually. So here is our question. So let's suppose we want to do this one. And step 1. So I'm going to write this one down like a template. There is an awful lot of work in these questions. They are massively big. And so I'm putting in like a little template to say what we do. The step 1 is choose an appropriate x sub. Well, we've already told you who that's going to be. It's going to be 4 sine theta. Are you comfortable that if someone gave you any of these integrals, that you would be able to use this as your reference point and choose the right x sub? Right. So if you see a number take away x squared, use a sine. If you see an x squared take away a number, use a secant. If you see 2 things added, use a tan. Right. That's basically the 3 guys. So only 3 guys in town. Step 2, find d of x. So let's see what we got. I have x equals 4 sine theta. I'm going to differentiate x with respect to theta, and that's going to get me 4 cosine thetas. I'll do the crossover. We're finished. So that's step 2. So step 1, pick the right x sub. Step 2, find dx. Step 3, convert your integral to thetas. So let's see what that looks like. I have the integral of x cubed over the square root of 16 take away x squared dx. Right? That's the one we're doing. Every x is going to be replaced by 4 sine theta. So this guy is 4 sine theta cubed. This guy inside the square root is 16 take away 4 sine thetas squared. This dx is going to be replaced by 4 cosine thetas d thetas. Are we good? So isn't that what you do with u subs? Don't you take an integral that's got x's and turn it into u's? Do you see in this case we're taking an integral with x's and we're converting into something using various trigs of theta. Now, style points. I know that's 64, but I'm just going to call it 4 cubed because I want to. And if you take sine theta and you square it, you get that. 4 and 4 get me 4 to the power of 4. Sine cubed theta, cosine theta, and you might wonder what I'm going to do with this ugly square root. Well, I'm going to pull out a common factor of 16. And yeah, I'm going to turn it into thetas, but I'm also going to do in its simplest form, right? Style points. Can you see anything that I can do with 1 minus sine squared? Can you see anything that's got 1 minus sine squared in it? What could I turn that into?
You can turn it into cosine squared.
Okay, so what we've got is this fella. I'm probably putting in more lines of working than you need. But I think for this question, it's probably a good idea not to cut too many corners. Do you notice that that bottom now turns into 4 cosine thetas? So what do I have? I have 4 to the 4 sine cubed theta, cosine theta. And the square root of 16 is 4, and the square root of cos squared is just cosines d theta. So far, so good? Now, there is a little bit of cancelling. Won't that cancel out with that and you get 4 cubed? And can I just tell you that 4 cubed is 64, and I'll stick it outside. And I now have sine cubed theta d theta. So the original integral that had nothing but x's using the x sub method has now become this trig function. I do not know the integral of that. I won't be able to get the integral of that typically by other means. But I do know how to get the integral of this guy. And that's going to become step 4. Find the integral in terms of theta. And let's see what we've got. We're trying to find 64, the integral of sine cubed theta d theta. And this is basically what we did in Monday and Tuesday. And there are lots of different techniques depending on the question. And this one is a sine cubed. Anybody get any ideas what to change sine cubed into that would allow us to integrate this?
Sine 10 sine squared.
Agreed. Somewhere on Monday or Tuesday, to be honest, I can never remember these things. Didn't we do a cos cubed or a cos to the 5 or a sine cubed or a sine to the 5? They're only like 4 guys, and that's one of them. Now, the reason we did that was so that we could call sine squared 1 minus cos squared. Agreed? Do you recognize a u sub? Right? Do not be surprised. X subs, large majority of them, you end up later on doing a u sub. Can you see how massive this question becomes? How many things you need to do just to get the answer? So in this case, won't you be, well, you tell me, sine or cosine, which is the right u sub? And there's only one that works.
Cosine?
Correct. Lucky guess, or was there a reason?
Well, we're just trying to get rid of that sine. And if you choose sine, then you can't get rid of 2 cosines.
Sounds like a plan. I agree. All I'm doing here is the usual messy working that you always end up doing. Hopefully you can see my little scribble, but basically I'm just doing that. So what do we have? We have 64 sine theta 1 minus u squared times -1 over sine theta du. And basically there's a -1 left over. Oh, I could do this 2 different ways. It really doesn't matter. Oh, let's distribute it. How about that? Okay. And so what do we get? We get a -u power rule. Agreed? So we comfortable with that? Now, oops, new page. Step 5. Change your answer back to x's, which is pretty standard, isn't it? Well, what do I have right now? I have, well, if I distribute the 64, I have -64 u's plus 64 thirds u cubed plus c. Since u is cosine, I have -64 cosines plus 64 thirds cosine cubed plus c. Everything looking good, right? Bad news. Everything's correct, but the bad news is we are going to have to figure out how to get these guys back to x's. And the way that you do that, if I can find my page, is we use this information. And I'm now going to do something I think for most of you, you have never seen this before. So hold on to your pantaloons here. There's some weird stuff going to happen. I'm going to use this piece of information, right, the x sub, to find cosine theta. First thing I'm going to do is I'm going to isolate the sine theta. And then I am going to go away back into my trig toolbox and I'm going to use SOHCAHTOA. You weren't thinking that was going to happen. Now, according to the SOHCAHTOA, isn't the sign opposite over hypotenuse? And then you're going to say, well, what use is that? Well, once you've created this piece of information, you build a little right angle triangle and you call this angle theta and you name the sides opposite, adjacent, and hypotenuse. And since you know the sine of theta is x over 4, doesn't that make the opposite x and the hypotenuse 4? How will I get the adjacent from this picture? Use Pythagoras. How will I get adjacent?
Four squared minus x squared.
Okay, and 4 squared minus x squared is 16 take away x squared, doesn't it? And it's the square root of it. Now here's the thing that is a good sign. At this point, see that guy there? Do you notice he's the same guy here? See that? If that guy there is not the same as this guy here, you have screwed up, stop and go hunting for the mistake. Right? Don't even continue because it's not going to be right. Now, from this triangle, can I find sines of theta, cosines of theta, tans of theta, secants of theta? Can I find anything theta that I want? And what do I want? Well, I want cosine of theta, don't I? I'll stick to red. Right, because my answer uses cosines. Well, isn't the cosine the adjacent over the hypotenuse? So a cosine will be the square root of 16 take away x squared divided by 4. So our answer, right, this is our answer up here, right? The integral of x cubed over the square root of 16 take away x squared dx, right? That's the question. It is negative 64 of this guy plus 64 thirds this guy cubed plus a c. Right, 4 and 64 partially cancel out, so I get negative 16 times that guy. 4 cubed is 64, so it cancels out with that 64. So I get 1/3. And this guy cubed is probably, that's the prettiest way to write him, plus c. 20 minutes. Would you agree this is the longest question you've ever done in calc? From start to finish, right? Pretty much the longest. Maybe you've found something bigger. Is it the longest question that you've had ever in math? Have you ever done a question that requires 20 minutes from start to finish? Pretty massive, right? And that is only one of the 3 done. So let's move on to number 2. This time, we're going to do that guy. And the x sub is going to be him. So there's stage 1 done. Stage 2 coming up. Differentiate this guy with respect to theta. If you differentiate a tan, you get secant squared theta. And you do the crossover, you get 2 secant squared theta d theta. Then we'll do step 3. Turn all of this into a simplified version of theta. So what do we get? We get the integral. Instead of x cubed, 2 tan theta cubed. On the bottom, the square root of 4 plus 2 tan thetas squared. Instead of a dx, 2 secant squared theta d theta. That guy is 8 tan thetas. This guy in the square root is 4 plus 4 tan square thetas. And this guy is 2 secant squared thetas. The 2 and the 8 get me 16. So I have 2 tan of these secant squared thetas, d thetas.
Wait, wouldn't the tan on the numerator be cubed?
Thank you. Yes.
These ones are too long to mess up somewhere in the middle. It'll
Oh
be
God,
dangerous.
no, you're right. Be careful. Don't screw up on the 4th line of working. That would not be fun. Okay, this bottom guy. Oh, let's go for it. Won't this guy turn into 4 1 plus tan squareds? Do you know what 1 plus tan squared is? Trig identity. What's 1 plus tan squared going to get?
Secant squared?
It is. So 4 secant squareds. And isn't 4 secant squared going to get me 2 secant thetas? So if you want to save 3 lines of working, can you do that? Can you trust me that that becomes that, just to save some time? Okay, you can fill in the 2 lines that go in the middle there. That cancels, gets me 8. That cancels with one of them. And now we are left with that guy. Move on to our next step. We are going to solve this integral. And it's either going to be a u sub or some trig identity. In this case, it's going to be a u sub. And you have to choose secant theta or tan theta. Only one works.
Secant theta?
Hesitant, but correct. Why?
Because it's going to turn into tan theta secant theta, and then that just leaves the tan squareds.
And we know how you deal with tan squares, right? So if you differentiate this with respect to theta, it's secant tan. And then crossover. And isolate the d theta, right? A little bit time consuming, but it's pretty standard. So we have 8 tan cube theta secant theta secant theta tan theta du. Have you noticed that when it's secants and tans, you don't turn any secants into u's yet, right? When it's sines and cosines, can't you turn all the cosines into u's and it's fine? But when it's secants and tans, leave them alone for a while. So we get some cancelling. And we get that. But isn't tan squared 1 plus secant squared? And isn't 1 plus secant squared 1 plus u squared? And so we are going to be integrating this guy. Are we comfortable with the u sub method for this one? Now, integrate 8, no, I don't know that. 8u plus 8/3 u cubed plus c. And I'm going to turn all the u's into secants. So it's now 8 secant theta plus 8/3 secant cubed theta plus c. Okay. So basically I'm on to take your answer, right, and convert back to x's. So now we have to deal with how to take the answer, which is in thetas, and change it back to x's? Well, you start with your x sub. In this case, you divide by 2 and you use SOHCAHTOA, and SOHCAHTOA is opposite over the adjacent. So I build my triangle based on the information that I get from here. And I have an opposite, I have an adjacent, and I have a hypotenuse. And the opposite is the top, so that's x, and the bottom is the adjacent, that's 2. And won't Pythagoras get me this guy? And won't it be x squared plus 4? And why is x squared plus 4 good news? Can you see it over here? It's called 4 plus x squared. Well, that's the same thing, right? So I now need to find secant theta. Right, isn't the secant 1 over the cosine? Now, since the cosine is opposite over adjacent, won't the secant just be the other way around? Opposite over, I should say adjacent over hypotenuse, won't it be hypotenuse over adjacent? Are you happy with that being the secant? It's just the reverse of a cosine. And the hypotenuse in this case is this fella. And the adjacent is 2. And so our answer, which was 8 secant thetas plus 8/3 secant cube thetas plus c, becomes 8 lots of this guy plus 8/3 of this guy cubed. That cancels to get me 4 square roots. 2 cubed is 8, so it cancels with that. I get 1/3, kind of deja vu. It looks kind of similar to the other one. It's a cube. And you're finished. I got that down to 15 minutes. Right, a little bit quicker. Did you notice that the process stayed the same, even if the details were a little different, right? The step 1, 2, 3, 4, all the way to the end. So when you get something that is as long and complex as this, it's easier in your brain if you just take it one step at a time, literally, right? Just do step 1. Okay, done. What do I do next? Okay, step 2, done, right? What do I do next? The last step is going to be this ugly triangle, isn't it? Where you take the substitution that you used, rearrange it so you can use SOHCAHTOA, build this triangle, and once you've got this triangle, won't you know sines, cosines, tans, you name it, you can get what it is in this triangle, can't you? You can convert, I can find the sine of theta, right? Won't that just be x over the square root? Right? You want a tan of theta, how about x over 2? Right? You want the cotangent of theta, how about 2 over x? Right? Everything is in this triangle. Phew. A lot to take in. Any questions? Okay, move on. Our last question for today. It's going to be x equals c secant theta. I'm going to differentiate. What is the derivative of 3 secant theta with respect to theta? What's a secant get you when you differentiate?
Secant tan.
Correct. Secant tan. And so when I do the crossover, right, we're finished. So I'll take my original and turn it into thetas in its simplest form. So it's going to be 3 secant thetas squared, take away 9. 3 secant thetas squared on the bottom. And dx is going to be 3 secant theta tan theta d theta. Right, the bottom guy is going to be 9 secant squared thetas. Okay, let's see. Would you agree that's going to be 9 secant squared theta take away 9? Sabina?
Is it squared, or in that top one it's to the fourth? Or
Oh, well caught. Thank you. Right. 3 secant, that's going to change my bottom number. Too busy worrying about what's going on there and not paying attention to the other stuff. 3 to the 4 is 81. So, right. There we go. Right. What will happen to 3 secant squared theta minus 9? Won't that become 9 secant squared minus 9? What trig identity is secant squared minus 1? Secant squared minus 1, tan squared. So will you agree that that becomes 9 tan squareds times 3 secant theta tan theta d theta? Are we comfortable so far? Okay. Won't that top guy then become 3 tan theta? And 3 and 3 is 9, cancels with that guy, so you end up with a 9 on the bottom. A secant cancels out a little bit, so you end up with a secant squared. And on the top, looks like we've got a tan squared. Are we good so far? Let me check that question, because there's something I don't like the looks of. No, that's not the one. I'm just trying to find which question from the homework I copied that from. I wonder if I copied it wrong. I may have copied it wrong. I did copy it wrong. That's squared. Sorry about this. That's squared. That's squared. That's 9. That's squared. That's 9. That's squared. And these all cancel. Right? And well, let's take it one back. So let's imagine we got to the line that looks like this. 9 tan squared theta over 9 secant squared theta, 3 secant and a tan and a d theta, right? So what we now have is 3 tan theta, 3 secant tan theta over 9 secant squared theta d theta. You have to be very careful that you write the right question down, because not every combination is doable, and the one that I just gave you, I did not like the looks of it, and I'm pretty sure it wouldn't have worked. Now I can 3 and 3 is 9, and that cancels that, which is fine. And now I'm left with a tan squared theta over a secant squared theta d theta. Right. Now I'm looking at that guy and I'm thinking, we're in trouble. And then I realized we're not. Any ideas how I'm going to tackle that? Because my first impression is, oh, it's probably going to be a u sub secant theta or a u sub tan theta, because that's what you get, right? And I just went through in my brain and I figured out that neither of those would actually work. So what is my alternate strategy to integrate this guy?
Would the secant squared on the bottom just be secant? Because doesn't the secant on the top
Oh,
second step cancel out?
right.
What?
So
Oh, okay.
secant, yes. Same problem. The u sub still doesn't work. But what shall I do then?
Would you have to do integration by parts with one of them being like 1 over secant theta?
Oh God, I hope not. That would be horrendous.
I was pretty scared by that, but I was like, you know what? These are long enough anyways. I wouldn't doubt it.
Yeah, I could imagine a situation when you did that. Here, this is what I'm going to do. I'm going to take this guy and turn everybody into cosines. And when I do that, I get that guy. I need a square here. Why don't I have a square here? Why don't I have a square here? I cancelled it there. Okay. Oh, okay, I'll go for it. This is a cool question. I think I've made a mistake with the original question, but I'm still going to try this one because I've got a feeling I might get away with this. I'm going to try a sine theta. I got 6 minutes to fight my way through this. It's going to work. It's going to work. I'm being an optimist here. It's going to work. Okay, so it's going to be u squared over cosine of theta times 1 over cosine of theta times du, which is u squared over cos squared theta du u squared over 1 minus sine squared theta du u squared over 1 minus u squared du. Darn it. It is doable, but you don't know how to do it yet. This is integration by parts. This is not integration by parts. This is partial fractions. Darn it. I guess my head's not in the game yet, which is probably a good idea for not doing it. Can we just say dot, dot, dot for the time being, because you don't have a technique for doing that. Somewhere or other, I either screwed up in the middle, which is possible and nobody found it, or that the correction that I've got does have a cube in it. Did I cube it right? This guy is question 12, and this fella here is a cube. Did I cube that? No, I squared it. Okay, I found my mistake. It was a cube, not a square. But I'm not going to go through it a third time. Can you trust me that if you do the cube to the bottom, you will get an integral that comes out nice, and we'll call it good. Yeah. So if you want to see what that question is, look at question 12 in your homework, and you'll see the x cubed on the bottom. But my brain is scanning up and down and all that other excuses for getting old. Right, well, 283 was not bad. Third one kind of died a death. Oh, let's finish something off. Let's pretend I did it correctly. Then wouldn't I have to turn the answer into x's, right? So I'm just randomly picking an answer. Can we pretend that the answer ended up being 9/2 secant theta plus 1/4 secant squared theta plus a tan theta, right? Just pretend that was the answer. Right. X over 3 is secant theta. You build your triangle. Here goes your theta. For a secant, okay. I know SOHCAHTOA is only used for sines, cosines, and tangents. But isn't a secant just an upside down cosine? So are we okay with me putting hypotenuse over adjacent, and you're happy from where they came from? So hypotenuse will be x, the adjacent will be 3, and this guy here will be the x squared minus 9 that we were hoping to get. This guy here is easy because he's x. And this guy here is easy because he's x, because he is x squared. But tangent of theta is just opposite over adjacent. So the answer would have been 9/2 x, 1/4 x squared, plus 1/3, that guy, plus 9. So if we pretend that was the correct answer, you would then have to turn everything into x's and finish it. Oh, and there's one possibility I didn't do. Can we pretend that there was a 2 theta as well? I need to turn 2 theta into x's. And I'm going to use that guy to do it. But I'm not going to use the triangle. Theta is the inverse secant of x over 3. So just in case you get a question and there's a theta or a theta squared, can you imagine that might pop out, you know, in one of the answers? You just have an inverse sine, or in this case, an inverse secant. And I did it with 2 minutes to spare, but that included a big balls up in the middle. So hopefully when you go back and redo that question with a cube, not with a square, not with a 4, but the guy in the middle, a cube, it'll come out nice.